Hello, I think this is recording. Yes. Okay, so this is the second time I'm making this video today because I guess it didn't finish compressing before I closed or something. So I did all this once and now it's gone. So I get to do it again. Let's hope I'm as enthusiastic. So I have my tools. Oh, there they are. Well, this is a little different. Oh, no. Okay, I wanted to use the annotate. Let me use that instead. Okay. Okay, so it says to simplify. So this video has like 5 or 6 problems, and they're mainly simplifying what to pull out from the radical, what to leave under the radical. When you're multiplying them, what do you do? When you're dividing them, what do you do? And adding and subtracting, there's one example. So just a few little things that might help you. So it says simplify. So the first thing I do when I see that is I'm going to put everything into exponential form. So 81 is 3 to the 4th because, 81, 9, and 9, etc. Each one is 3, 3. So then you have x to the 6th. So you have options here. You could do x cubed and x cubed, and you can do y to the 3rd times y is y to the 4th. And I'm going to show you this once with 2 different scenarios. The problem with this whole thing is that you can do it different ways. A lot of you did discussion forum, module 12, and you can look at other people's work and they did it completely different than you. So that doesn't mean it's wrong. They just did it a little differently than you did. Oops, why did I do that? Maybe I can't talk and work at the same time. Okay. So some of you did the following. You said, hey, I need a 3 out here because if this 3 here matches that 3 index, so if my exponent matches my index, whatever's inside there comes out. So I'm going to put an x squared because 2 times 3 is the original 6. You see, I'm going to try to use spotlights, but this too, whoops, where did it go? I want my spotlight. Oh, it's not letting me bring that over. Interesting. Technical difficulties, but that 2 and that 3 makes the total of 6, or x cubed times x cubed is x to the 6 because you add them together when you're multiplying, right? So this is from chapter 5, right? And x squared cubed is x to the 2 times 3. Those are the product rule and the power rule, so you got to be careful with this. And then on the y's, we have a y cubed and a y. That makes y to the 4th. And my goal, again, is to have an exponent that matches my index. That's why I did that with the to the 4th power. So we have, if I continue on the green, this isn't the smoothest I've ever done something. I should have done that. That's fine. My subconscious was trying to do it the way I should have been doing it. And then this 3 matches my index, so that 3 comes out. This 3 matches my index, so whatever's in parentheses comes out. Let me clean that up some. It's too long an arrow. So the x squared, whatever's in the parentheses, that comes out. Then this 3 matches my index, so the thing it's attached to comes out. So in this case, just a y. And then you say, what stays under? I still got a cube root and the 3 to the 1st, so that's just a 3. And then you have y to the 1st, and that just stays. So this is my final answer. If you do it the other way, in this case, you're still going to do the same thing with the 3. Always extend that radical over. Otherwise, not technically out. So that 3 comes out, then that x comes out, and this x comes out, and then the y comes out, and then what stays under is the 3 and the y. and then you have to turn around and multiply the remaining things that you had pulled. You see how it's exactly the same thing. Another deal, some of you would do the cube root, I'm gonna work over here to the left, cubed root of x to the 6. You would use the fact, you know, different rules can be applied, but they all get to the same answer. Some of you know that the nth root of a to the m is a to the m over n, and we did this last time in the previous video. The index is always in my denominator. So in this case, it would be the index is my denominator, and that would create an x squared. So some of you do it that way. There's absolutely nothing wrong with that. So that's how you end up with this x squared here. So when you use this method from radical to exponential, you actually go immediately away from the radical, where I decided over here and over here to keep my radical and just to create exponents that match my index. So lots of different ways to work these. You'll just have to find something that you like and not get upset with me or anybody else for doing it differently, because there's just a lot of options. Oh, I'm using my mouse and it doesn't work. Hard. Okay, here it says use the quotient rule. You could work this different ways if you didn't want to pay attention to instructions, which when I look at discussions, sometimes I wonder if you all are paying attention to instructions, because people are doing whatever they want. They're supposed to follow directions. But if it says use the quotient rule, they're really telling you to use that rule, that if the index is the same, you can go under. You can also go in reverse. Sometimes it helps you to split them up because one of them might not be evenly divisible. So sometimes it helps you to go one way, sometimes it helps you to go the other way. In this case, you could just take that numerator and you could simplify it. You know, but look at this, just the fourth root of a to the 19th. If we're just looking at the a's, do you see how that would, you'd have to, you need to get close to the 19, but you can't go over. So you would have a to the, we need a 4 here to match the index. You can't go over the 19, but if you put a 4 here, you're going to get 16. 4 times 4 is 16, and then you'd have 1 left over. And what you would then do is that a to the 4th comes out, and then the 4th root of a would be left. But that's just the numerator. Then look at the denominator. You have more a's in the denominator. So when it tells you to use the quotient rule, do yourself a favor and use the quotient rule, because it'll help you. So you got the 4th root of 400 a to the 19th b to the 3rd over 5a cubed b cubed. And then you can simplify underneath before you fiddle with what comes out, what stays under. So if 100 divided by 5 is 80, a to the 19 over a cubed, if you cancel common factors, you have 16 left over, or you can use the quotient rule. This is from chapter 5, right? If you're dividing, you would subtract the exponents. And then b cubed, well, you can use the quotient rule. What is b to the 0? 1. Anything to the 0 power is 1. So it just disappears. Or you can say, well, b cubed over b cubed, they just cancel. So regardless, this is what you're left with. Then you have to create those exponents. So we would take the 80, and you know, calculator or not, if you don't have one, I don't have one handy right now, and I don't feel like messing with it. These are all the primes that make up that 80. You learned this in pre-algebra and below. So what do you have here? You have 2 to the 4th power times 5, and you see how you don't need a calculator. We need a 4. Well, in this case, it's cake, because 4 times 4 is 16. So what comes out? Well, this one matches the index, so the 2 comes out. This matches the index, so whatever it touches, comes out, so the whole 8 to the 4th comes out, you see, because that 4 touches that parentheses. And then what stays under that. And another one, a thing that's the biggest mistake that students usually make is they forget to write that index. Once they put a radical, they just put a square root by accident. Be careful that you always put that index. It started out as a 4. You can't just change it into a square root. Okay, clear. Let's see. Will it let me mouse now? Nope, still not. Okay, that's okay. We can work it this way. Use a quotient rule. So we're going to do that again. 64 divided by 2, 32. Wait, this is interesting. X to the 10th over x squared. So let's look at the x's. Interesting. It disappears on me if I move it over here. I think it's trying to use the other items. I want to use this. Okay, so it was using my word part. Okay, we'll just do it over here in green. X to the 10th over x squared is x to the 8th, right? I have 10 upstairs, 2 downstairs, cancel. So this is an x to the 8th. And then you have your y's. And if we're just looking at the y's, I'm going to do it over here on the left. We went over this in the last video. I said, hey, exponents are attitudes. Think of them as attitudes. And if you see a negative attitude, you're going to move it upstairs or downstairs, depending on where it was started out. But we're going to move it. So this guy started out negative downstairs. So we're going to move him upstairs, which causes y to the 15th. So we have a y to the 15th. So you don't want to flip the whole thing. You're just moving the one that has a negative exponent attached. And when you move it, the exponent becomes positive. Okay, so let me use the blue here. So we have the 5th root of 32 is 2 to the 5th power. X's, I have 8. I could split that into the x to the 5th times x cubed. Y to the 15th, I could write y to the 5th 3 times. Or I could write, I need a 5. I have a y. What do I need here to make that 15? How about a 3? 3 times 5 is 15. And then everything that has the exponent of 5 comes out. So the 2 comes out, the x comes out, the y cubed comes out, and then the 5th root of what stays under, just the x cubed. And I hope I don't make a mistake. Sometimes while I'm making a video, I make a mistake because it's harder to catch everything. Yeah. Okay. And if you want to use the exponent rule, you know, you change this into an exponential or an exponent that's a fraction, you know, that's okay because you're still going to end up right there. So, and you know, if you don't like this, you could do with the 15. Y to the 15 thirds is y to the 5th, which is, oh, oh, 15 over 5. See, I knew it. See, I messed up just now. I caught it though. Why did I make that denominator 3 when it was supposed to be a 5? My index is 5. See, I shouldn't elaborate. Okay, that's okay. I caught it. Clear all drawings. Oh, see how that doesn't disappear. Here's 1, multiply. Interesting. Draw. So this one here we do in class usually, and it messes people up. So let's look at it. You have a q. The thing is, this exponent is on the outside. It affects everything inside. So the best thing to do is, you can't go under right now because you always do exponent before you multiply. This is technically multiplication, right? So we still follow regular order of operation, but you could write it like this, right? You have that factor 3 times. So then when you use the product rule is the nth root of A times the nth root of B is the nth root of AB, because when you're when you're multiplying, be careful with this, you have to be multiplying or dividing. That if the index matches, these two match, you can go under. So in this case, it would be cubed root of 3 times 3 times 3 square root of 3 cubed A cubed. You see? Seems a little tedious. Some of you will look at this differently and say, hey, the square root of 3A cubed is the square root of 3 cubed A cubed, because this exponent affects everything inside, and that 3 times 1 is 3, and 3 times 1 is 3. So I like this a lot better. So I'm going to clear this and start over. But you first need to deal with this exponent. You can't be putting them underneath. So we're going to have a 3 cubed times A cubed. Then you have a square root of 2A to the 7th. And some students will take this thing and go ahead and try to simplify it and do to a, they want the 7, so they want a 2 here, and they do a 3 times 2 is 6, and there's one more. When you have something like this, it's always better to first go under, because you have A in both of them. So you're better off going under and then doing this process. So don't do this process here, because you're going to have some that come out, and that A here stays under, and you're better off dealing with it all at once. So let's look at it. 3 cubed times 2, and don't make a big number because you'll have to take it back apart. A cubed times A to the 7th is A to the 10th, because, right, the product rule, you add your exponents. So then you make it into, what do you need? You need an exponent of 2, because if this is blank, my index is 2, right? That's a square root. So don't think that's a 1. So we need an exponent of 2. So we can do 3 squared times 3 times 2 to the first. Those are first powers. You don't need to show that. And here you see how the A's, you can deal with them all at once instead of, here and here, fiddling with those separately. You're much better off doing them all at once. So we need a 2. What do we have to put here? We need a 5. 5 times 2 is 10. Power to power, multiply. So now all the ones that have a matching index, all of the ones that the exponent matches the index come out. So the 3 comes out, the A to the 5th comes out. And then what stays under? 3 times 2 is 6. And I guess that's it, because everything else came out. So there's the answer. Keep it simple if you can. Okay, so, gosh, I really hope this recording records, because I'm going to get tired of repeating myself. Okay, here is. Do you see how you have a cubed root of something and a cubed root of something, and you're just multiplying? There's no exponent on the outside. So again, instead of doing these separately, you need to go ahead and put them under, because then your life will be easier. A to the 5th. Do you see how if you fiddled with the cubed root of B to the 8th, it's not evenly divisible? That would take a while. And then you have a cubed root of B to the 4th. That would take a while. And then you'd have to combine together what you pulled out. So we're going to do this all at once. We're going to go under and say B to the 8th times B to the 4th is B to the 12th. And then we have a C to the 10th. Then we take and we find an exponent that matches the index. A cubed, how many more do I need? 2. B to the 12th. We need a 3. We can put a 4. 4 times 3 is 12. C's, we need a 3. Not evenly divisible. 10 is not evenly divisible by 3. But we can get close, and we can go to a 9. And then we have one more, right? So 3 times 3 is 9 and 1 is 10. Then you say, okay, what matches my index? That one. So the A comes out. This matches my index. What comes out? The thing it's attached to, the whole b to the fourth. This matches my index. What comes out? The thing it's attached to, the whole c cubed. And then you say, I have a cubed root. What stays under? A squared and c. And there's your final answer. So we're getting there. I think we have one more. If I lose this video as well, then the next time I record this will be super fast. But I'm going to hope it works. Add or subtract. So when you're adding or subtracting, it's very important. If you're adding or subtracting radicals, you need like terms. And then over here, I'm going to go back and look at a little bit at a pre-algebra. What if I had 3x squared plus 5x minus 2x squared minus 1 or 7x, let's say. Then you would say, what on those ones, when do you combine them? Adding and subtracting you do when you have like terms. And in that case on the right, the green stuff, like terms is same variable, same exponent. So you have 3 apples minus 2 apples is a single apple. And then you have $5 in the checking account and you write a check for $7 and you'll get negative $2, you see? So then you can't combine the rest of them because you have to have the same variable, same exponent. Well, same thing goes for radicals. We need the same index and the same radicand, because that's really what this means. If you wrote those, radicand is the thing under the root. The whole thing under the root has to be the same. So when you have add and subtract, you can't go under. Okay, so on this, you can't just say, oh, I have square root, square root, square root. I can just do all those under. What you have to do is you have to simplify each one and then see where that leads you. It's a square root. 16 is 4 squared, or you can do 2 to the 4th and deal with it that way. You have an A and you have a B to the 9th. I need an exponent of 2. Maybe this should be a 4. 4 times 2 is 8, and then I have one more that makes the 9. Always extend your root over. Minus square root. 49 is 7 squared. I need a 2. A squared squared. 2 times 2 is 4, and one more is the 5. B to the 9th. B to the 9th is 4 squared and B. And you know what, in this specific case, you could have, and this is not intentional. This is in the homework, and this is an accident that really these two are exactly the same. You could have just said, I borrow a mess, I pay back a mess, and they kind of cancel out. So if you saw that ahead of time, I'm not against it. It's just not usually going to happen. Usually you have to work this. So yes, in this specific case, because it's a weird problem, I admit it, you could have gotten away with not knowing what you're doing and just adding them. But we're going to do it to where it always works. So A squared squared, A, and yes, they're the same. B to the 9th. Same, same, same. But such is life sometimes. Okay, this A squared comes down. What comes out? A 4. What else comes out? A B to the 4th. So if you want to circle those or mark them somehow, and whatever they're attached to is what comes out. And then what's left over, square root of AB. Minus 7 comes out. A squared comes out. B to the 4th comes out. AB. 7. a squared comes out, b to the fourth comes out. And then usually, okay, for the first one, you would call it 4a squared b to the fourth, because you can rearrange it, you know, it's multiplication. But I don't want to waste my time too much here. This is where you want to think of dollars. I have $4, right? $4. So this is what you want to think about. This is the dollar minus $7 plus $7. And yes, in this specific case, these two cancel each other out. So your final answer is gonna be just this. This is not a good example. I should have grabbed another one. I didn't notice it at the time. But still, when you're adding or subtracting, you simplify each one, then usually, maybe not all of them, but some of them turn into like terms. Like terms, same index, same radicand, same variable, same exponent. So this is where this comes in. Okay, so I hope this clarified a little bit, and hopefully I can save this so I don't have to do this again and sound even less enthusiastic. Keep asking questions, keep sending me my lab, ask my instructor so that I can make videos and help you, okay?